Okay. So homework questions, other questions, textbook work questions? Number one on the homework, which one was that? Let's see. So the turn-in ones, you mean?
Yeah.
So fractions. Okay, so we have 2/3 of a cup. A point we might see later, but I want to make it anyway, is that on the website, unfortunately, the way HTML coding works for websites, I have to make fractions that are sort of diagonally to each other. And it's much better, especially once we get to proportions, to always make your fractions one number directly on top of the other. So whenever I write them by hand, I do it this way. If you are used to diagonalish fractions, then that's a good habit to get out of. Write them this way, you will be happier and make less careless mistakes. So, okay, so I have 2/3 of a cup and I want to double it. So what's the math for doubling something? Times 2. Okay. So I want to do times 2. Any number that's a whole number, I can make into a fraction, put it over 1. And then how do I do fraction multiplication? Just go across the numerators, go across the denominators. And 4/3 a cup might be the answer. If this wasn't multiple choice, I could just put a box around it and be done. It might ask you, because it's multiple choice, to write it as a mixed number instead. In which case, you have 3 of your thirds makes 1, and then you have 1/3 left over. If you don't remember the arithmetic ways to go from an improper fraction to a mixed number, just draw some pictures. So either of those should be happy.
Thank you.
Okay, good question. Other homework questions?
Can you go for number 5 of percent format?
5 in the percent format homework, sure. This one?
Yeah.
Okay, so I have 0.8%. I want to get rid of that percent symbol and replace it with something else that means the same thing. I also want to fix the 0.8 to make it friendlier, probably.
Would it be 8/10?
So we could make it 0.8%. This is one way to do it. If I change the 0.8 to 0.8, I still have the percent symbol to deal with, right? That didn't go away yet.
Times 0, times 0.
So if I did it that way, then I can say that this is 0.8, and this is a times 1/100, and I can get 8/1000, and divided by 4. No, I can divide by 8 for all of this. So 1,000 divided by 8. So that's one way to do it, where we're dealing with the 0.8 part first. The other way we could do it is to deal with the percent sign first. So I went left out of percent. And now I have to make it into a fraction. So I would say 8 thousandths, looking at that, right? Tenths, hundredths, thousandths. So I would get to the same 8 thousandths. It would just be a different path. Does that make sense? So you don't have to do both, but it works either way. I can say the 0.8 bothers me. I'll change it into a fraction first because that's getting me towards the fraction answer I want. Or you could say the percent symbol bothers me. I'll get rid of that first and then just have a decimal to make it into a percent. So.
Do number 8.
Can I do number 8? Let's see. Write that one as a percent. Okay. So for fraction to percent, then the fast, reliable, use a calculator way was just to treat it as division. And that's great because if you have a calculator, which in real life you always have your phone probably, then 17 over 50 isn't a bad thing at all. The calculator handles this first step for you, or the second step. In this one, you could be really clever. You could stare at 17 over 50 and say, you know, since I am such a thoughtful, clever person, I can make the bottom into a 100 and see that it's 34 out of 100, and 34 over 100 would be 34%, because over 100 was one of the things that means percent. But usually by the time the clever person has figured out that, oh wait, 50 is one of the times I can do this trick, then everyone else has just done it the top way. So it doesn't actually save you any time. But if you like being clever, then pause at the beginning and say, is the denominator something I can make into 100?
Number 6.
6. Let's see. Didn't I do that one? I did a similar one last time.
Okay.
So I will go over how, but I'm not going to finish it for you. So check Wednesday's notes. But in this case, the stumbling block isn't the mixed number. The mixed number, we're always going to say, I don't like mixed numbers, let's make an improper fraction no matter what we're doing. So if I have 8 quarters, that's $4. So 25 times, no, $2, I'm sorry. So then 25 times 8 would be 200, plus 3 is 203 over 8%. And then I want to get rid of that percent. And which of the 4 things do I want to make it? The times 1 over 100. So the last little step I will leave for you to do yourself. Yes. Number 2. So many places and then right or left. So if we're multiplying by something tiny, we have only 1/100th of your birthday cake left, or whatever this object is, then is it getting smaller or bigger? Bigger? No, if you have only 1/100th of it, you have a small amount, right? Most of your cake is gone. So is smaller going to be to the left or to the right? To the left. And then it's 100th. So how many scoots will you have? 2, right? 10 would be 1 scoot, 100th would be 2 scoots. Okay, let's go back to something I need to do. So we've talked about different ways to write notes. We've talked about some test-taking strategies and how to use a test well to study and know what you're doing and get something that's complete and ready to cram on the final exam. So we've talked about how to do homework and why you have so many different flavors of homework in this class and why they're put in the order they are. So what we haven't talked about is how to write things neatly and step by step. I've hopefully modeled this well for 3 weeks now, but let's actually talk about what these things are. And one of your checkmark achievements will be to turn in step-by-step problems. You get 1 checkmark when you get 10 of them, and another when you get 20. And you probably have 20 nicely written things already by now. But if not, don't worry, it will just happen anyway as you do the class. As for most of the things on the website, read this carefully at home. I'm just going to go over some highlights to use up class time, but I'm not going to use up class time reading every word to you. So this one I don't see much problems with. Most people in Math 20 are legible. Every now and then I will get someone that wants to use like graph paper, which is even shorter lines than colored ruled paper, and then try and write fractions, and I can't read them, but that's not really a problem. So that's not too bad. This one I mentioned, write your fractions vertically. Don't make diagonal fractions. When we get to proportions, it will cause you pain. Don't mix up your dots. You don't have to use dots for multiplying. I have that habit because I don't like X's for multiplying because they look like the letter X when I handwrite. But if you do use dots for multiplying, don't make them look like decimals. And I have trouble with this on the board. They changed the software over the summer. It used to be until this school year that if I wiggled my pen, it would make the dot bigger on the screen. But now it's on sort of autocorrect mode. It's trying to help me be neat. So if I wiggle the pen, I can't make my multiplication dots bigger than the decimal dots. So I have to go only by if they're lined up centrally on the line or down at the bottom. And it's a little harder for you. I have figured out how to turn that off, but then it makes things look funny. So let's see. Okay, 4 steps are clear and small enough to answer what was I thinking here. When we get to proportions, we'll talk more about that. But so far, just use what you've seen me do on the board, that you can tell what I'm doing in each step. Each step is on its line. Proper math grammar, we don't really have that much yet. We talked about when you're reducing fractions, there was one bad way to write it, using like a single divided by 2 to mean divide the top and the bottom by 2. But that would actually be divided by 2 over 1, which is not what you're doing. You don't have a lot of math grammar to use badly yet, so that's not too big a deal. This one will be important very soon. When we have things with labels, put some labels on them. You don't have too many things where where you use a label in the middle. So far, it's mostly just if it's a word problem, put the label on your answer. But we'll have labels appearing in the middle of problems soon, and it will be important to do things right to keep track of things to have the labels. 7, I want to write bigger. Or I'll just make it look bigger. So for 7, where's 7? There we are. So a single line can include more than one equal sign. That should say equal sign, not equation. Anyway, if everything really is equal. So if we have that some letter is 7 plus 8 plus 9, I can say, well, the 7 plus 8 is 15, and there's still plus 9, and 15 plus 9 is 24. So we have 4 things here, and they are all 24. So they are all equal to each other. What I sometimes see, which doesn't work, is to add things that aren't equal because you're having a flow of thought. So we'll say that y, well, first we're going to add 7 and 8, which is 15. And the next step is to add 9, and then we get to 24. And this is 24, and this is 24, and the y that we're looking for is 24, but the 7 plus 8 isn't. That makes sense? So you're linking things, and not all of them are actually equal. And it's not going to cause too many problems in Math 20, but if you go into Math 60, then this can really mess you up. So if you're doing equal sign to mean train of thought progress, then no. Use a new line for each step. Or maybe if you really have to, then you can always use something that looks more like an arrow to say, okay, I'm moving on to the next step in my thought. But that's not what equal sign means unless it actually is equal. Okay. Now we're too big. Okay. Problems are clearly numbered, spaced sufficiently apart, and easy to find. It doesn't say in order. An important part of the test taking strategy is if you're taking a test and you get to a slow problem and it's only worth the same number of points as a fast problem, then skip it and save it to the end if you're worried about finishing. Or if you start something and you get stuck, then probably just skip it for now, leave some space on the paper, and keep going. So I don't need you to do all your problems in order. I just need to know where they are so I can grade them. Enough of the original problem is included to allow double checking for copying errors. Again, later in the term, this will be more of an issue, but we're not doing too many word problems yet. Everyone has sort of half dyslexia where sometimes you get things wrong because when you're moving from the page to your scrap paper, you copy something wrong. So we'll talk more about this when it becomes appropriate. Appropriate parts of the problem line up vertically. Equations are solved with the vertical format. So let's look at what we have done today. That one doesn't have more than one equal. So when I'm working from step to step, my equal signs should line up. If I have letters, usually my letters line up on top of each other, so that keeps me organized. Work is written horizontally to emphasize terms and leave room for fraction, reducing, and unreducing. Then we haven't done anything with terms yet. We'll get to that word soon enough. But when I'm writing things, then if I was to squish this equal sign over here, I wouldn't have room to write what I'm doing to this fraction. So there's times when you're working horizontally where you leave some space because you know you're going to be modifying your fractions. Off on a tangent work is off to the side so that if you're in the middle of doing a problem and going down nice steps and suddenly you need to do some long division or multiply some fractions or something like that, then don't try and squeeze it in your flow of thought a bit. Steps with the equal signs. Do it off to the side and then put it back where you need it. You'll see that. When you use labels, use the right labels, and the ones that cause problems in this class are the M's. Meters is M, miles is MI, units is MIN. So don't confuse me or the people you're working with by using the wrong M's. Make your answer easy to find. Some people have such neat writing that they don't have to do anything at all. But for most of us, it's nice to put a box or highlight or something to make it so you can find where the answers are. If it's a word problem and your answer needs a label, make sure there's the label. And the one we all love so much, if you have a fraction answer, it has to be fully reduced. So there's more examples of those if you want to see them from students of past terms. If you want me to share yours for posterity, there's plenty of room here for me to scan and put more things and you can become famous. hopefully this isn't anything surprising because you've seen it in other classes and I've been doing it for 3 weeks, but it's part of my responsibility just to sort of point all these out. This is what I'm looking for. This is what other math instructors will look for. Because maybe no one actually showed you this list of them. Okay, questions about that? None at all. Okay. Let's do just a tiny bit and then something different. So we ended up Wednesday with a cliffhanger that when we're adding fractions and want common denominators, and subtracting works the same. I'll just talk about adding to be simple to start. Then we need common denominators, and there's 3 different cases. Case 1 was where one fraction denominator was a factor of the other. Or if I look at it in the other perspective, the bigger one is a multiple of the other. And that wasn't too bad. I can just say, what do I need to turn 7 into 14? And to be fair, if I do it on the bottom, I have to do it on the top. The second case was where they were relatively prime. So there's a number. 3 doesn't go into 10. 10 isn't itself prime, but compared to 3, it's relatively prime. There's no common factors. In that case, the best I can do is multiply each one by the other. And again, to be fair, if I do something on the bottom, I have to do it on the top. I suppose I might as well finish these, huh? And I'm forgetting that 3 as I'm writing. Oh, okay. So those were each straightforward in their own way. I don't have to think about what to do. If I notice that one denominator is a factor of the other, then I can just make them match by only changing one of them. If I notice there's no factors in common, then, oh well, I have to do it this way.
I
Yes.
see that you added 10 plus 3, which equals 13. Why didn't you add 30 plus 30?
Because in this case, 30ths are the size of pieces. I have 2 cakes cut into 30 pieces. One of them has 10 slices left. The other has 3 slices left. So I can still serve 13 more people these pieces of sheet cake. So think of the denominator like a size. It's like oranges or apples. It's just how big these things are. It's a label. The more interesting case, only because it's confusing, is when there are some factors in common. So let's look at that. I'll make it 1/6. So now there is a 2. That's a common factor of both 4 and 6. I could brute force it and say, let's multiply each one by the other. That will still work. There's nothing wrong with that math process. But it's almost always true, might be even always true, that if you do it that way, you'll have to reduce your answer.
Yeah, I got 12. Okay.
So So there must be a better way to do it. Just like reducing, when we were multiplying fractions, let us avoid having some bigger numbers on the page. Remember there was a 70 on that one slide? That 70 wasn't wrong, it was just annoying. So in the same way, we want to do something a little more efficient. And as this divided by 2 hints, the problem is that there was a 2 in common here,
Yeah, sure.
and we ignored that. We just brute forced it using the other method. So can we do something clever to not have that 2 show up in our answer? And there's 3 different ways that people handle this.
You just multiplied it by 2 at the beginning to get the common denominator is 12 instead of doing the long.
It's how to get the 12.
Yeah, it's basically.
I'm using small numbers now that you can probably, if you've done this before, just look at it and know 12 is your common denominator. But let's pretend that we're not good at this yet, because if the numbers were less friendly, then we wouldn't be that good at it yet. So the first method, 3 methods for adding fractions, is that brute force method. We just did that one. Let's not do any tricks. Reducing isn't so bad. The second is list of multiples. So I'll say, oh, I can list multiples. We have 4, 8, 12, 16, and we have 6. And as soon as we get to one that matches, then that's going to be the smallest multiple. Just look on the page, right? All the multiples are there that I might want, and I picked the smallest one. So if you like multiplying, bigger numbers don't scare you. Maybe you have good calculator speed and can make lots of multiples fast, then this is an easy way to do it. Then I have to look and say, well, my lists tell me I want 12ths. So how do I get from 4 to 12? There's 2 things you could do. You could either say, I know that 4 times 3 is 12, because I'm good at my times tables. And if I do it to the bottom, I have to do it to the top, and so I'll get 3/12. Or if just looking doesn't work, then you can say 1, 2, 3. It's the 3rd on my list. If it was a bigger number that you didn't have your times tables for. Maybe instead of multiples of 4, we're doing multiples of 17, and you don't have those memorized. Similarly, for my 6, how do I get from 6 to 12? I could either just know my times tables, or I could say, whoops, we have an orange highlight? We do. Or I could go 1, 2 there if I can't get the 2 just by looking at it. Okay, 1 times 2 is 2, and then we get. So that's the list of multiple ways. It's for people that don't mind bigger numbers, because multiplying is a pretty simple, friendly thing, especially with the calculator. The other method, it has more than one way to write it on the board. So I'm going to show you a way that I've seen people do before, and I've had people with different Math 10 backgrounds say, I really like this way. And so if that's you, then on Monday I'm going to have you come up and write your way on the board. But we don't have time to do lots of sharing today. So the gist of things is we want to make factor trees for both numbers. And then get rid of the duplicates. And it's the getting rid of the duplicates that fits on the page in different ways. What some people do is they list it out. And if there's a duplicate, they put it underneath the previous one. If there's not, then they space it out and keep going. And then when they're done, they can say, those sort of these duplicated ones will merge together. We don't need both copies of them.
Yeah.
For other people, this little part of the corner of the board doesn't look friendly. It's too much like adding or something, and we're not adding. So then there's other ways to do this. What some people will do is on the factor trees themselves, cross out the duplicates and make sure that when you're checking what's around, those are like one thing. We have the 2 that is shared, another 2 that's not, and the 3 that's not shared. And there's other ways of writing this, but the goal is to try and get a list of all of the prime factors, but if there's duplicates, only list them once in our end result. So I'm not going to do more example problems now, but I know if the weekend is coming up and some people are almost good at this and not quite and want to do stuff on the whole.
Do we have to use that last way? Or?
No, if you like the multiples way, that's great. And even if you like the brute force way, that's okay, although that tends to be the longest and make people hit their head on the table. So, but that's why I'm showing you 3 ways. If you like the multiple ways, because that just makes more sense, then go ahead and do that. So on the website, that's this thing here, brute force method, list of multiples or prime factorization. Okay, now on to something completely different. Okay. Why am I wanting to measure with a pop quiz? I don't want to measure how much math you know at the end of week 3, because no one in the world cares how much math you know at the end of week 3. Right? On the final, I'll know how much math you know then, and that's what people care about. I don't want you to fall behind in class, especially this friendly but not turning in collection of boys in the corner there. If you haven't turned in homework, I'm getting worried about this. Like, maybe you're on top of things, maybe you're not, but proving it that you're not falling behind would make me feel better this weekend. But anyway, hopefully the turn in homework is making you not fall behind. I don't need to grade you to encourage you not to fall behind. I can just have you work in groups, and then you don't want to feel stupid sitting next to someone, and that works well. So the thing we haven't done is, can we use your math tools in a real life way? You might have this bad impression that math is all about getting the right answer compared to other academic subjects, but that's wrong.
Isn't it?
No, it's like that for 2 reasons. One, because it's easy for people to grade when you try to get a right answer. And so a lot of math classes want you to get the right answer just because it's easy for the instructor to grade you. It's also this bizarre thing where, have I talked about reading and writing and stuff yet? I don't think I have in this class. So I have an 8-year-old who's reading Harry Potter. Right? He's reading. I mentioned this one. No one expects him to write as well as Rowling does. But for some reason in math, you're supposed to be able to take in what I'm doing and explaining and produce it at the same level. Right? Language doesn't work that way. History doesn't work that way. No one expects you to be a professional historian just because you're reading something about Mesopotamia or whatever. So that's why people don't like math. It's like if English made you write essay questions at the same level of your reading ability, and that was what people thought English was, no one would like English either. So I need to show you some cases about math that's more realistic, that's not always getting the right answer, because there is a right answer and everyone knows that. So here's what we're going to do. We're going to do a pop quiz, but just like the midterms were not what you were expecting, the pop quiz is not what you're expecting. If this doesn't work, great, I'll go back to the kind you're expecting. I'm going to use Abdullah as my example. So if he's at work, then Abdullah is working for whatever, National Hover Carts and Company. He's a good employee, and business is falling down. right? So his boss comes to him and says, the CEO has got 3 business plans for National Hovercarts. Which one is the best? You need to figure this out because we've heard you're good at math. And by the way, we're going to lock you in a room. You can't come out for an hour. You can't use a calculator, and you can't look at any books or websites or reference materials. Would that ever happen? No, right? Future of the company depends on you, right? So in real life, not only are the problems not having a single right answer, but you're allowed to use these resources. So I'm going to have our pop quizzes be when we do that. Your goal is to decide if you should rent or buy a house. And this could be realistic numbers, because maybe you're house shopping, or you could just make some up, but try and make them useful, or trying to actually give advice to people here. So pick a location you have experience with. This was probably Eugene and Springfield, but maybe not. If you just moved here in the fall and you're used to somewhere else's housing market and rents and utility bills and so on, use what you know. You could work in a group, and we're going to see how well you use the unit rates, the measurement unit conversion, changing the fraction and percent that we've been dealing with. And I'm giving you steps. So in a moment, I'm going to hit send and you'll get this in email. You also can look at the board. I'm not going to grade you on the numbers you get, because what you think utilities cost and so on will be different from one person to another. But your process, I can see. I'm going to grade you on your process. Do you have organization and neatness and thoroughness, and do you actually get a meaningful result? So let's look at the steps before I hit send. First, think of at least 2 things that are monthly costs for renting a house and 2 that are monthly costs for buying a house. Have a similar house. It's not a fair comparison if you're like, should I buy a mansion or rent a 1-bedroom? Then think about non-monthly costs. And if you have trouble brainstorming, I've given you some examples. You can make up your own too. Convert everything to a monthly amount, because you can't compare the apples and oranges. So get monthly amounts for everything. Then add them all up. And you'll have a total of what are the monthly costs to rent and what are the monthly costs to buy. You're not going to do a perfect, accurate job. No one's going to include every factor of homeownership. But part of your decision making is which things to include. Then have a ratio, the smaller to the larger, right? The smaller one is about 3,000, the bigger one is about 5,000, because we're talking about mansions. And so my ratio is 3,000 to 5,000. Then change that to a percent when you're done. You would take 3,000 divided by 5,000 and rip-flop it. And at the end, write a couple sentences. How did you decide which factors to include? How confident are you? Is your answer meaningful? And this is only the math, not like, is it good for your family? So what other things might be there? So you have 10 minutes. You could do this by yourself. You could do it as a group and see what answer you can get.
I